Hello and welcome to Module 6 of the NDI Basics course, where we'll be exploring one of the most critical aspects of NDI workflows, discovery and registration. Now, in traditional AV systems, devices are typically connected via physical cables like HDMI or SDI, making identification simple based on the connection. However, in an IP-based system like NDI, devices communicate over a network, and identification is based on network addresses rather than physical connections. This makes discovery and registration processes essential to ensure seamless communication between those devices. NDI simplifies this by offering zero configuration discovery options, which means that devices automatically identify each other without requiring complex network setup. So in this module, we're going to cover the two key discovery methods, MDNS and discovery service. These mechanisms allow NDI-enabled devices to locate each other and begin transmitting audio, video, and metadata over the network without manual intervention. One of the major advantages of NDI is its ability to operate with zero configuration. In traditional AV systems, each device has to be manually connected, but NDI allows devices to communicate over the network without needing predefined addresses or complicated setups. Crucial, really, for large-scale productions where hundreds of devices might be connected, and managing manual connections just would be too inefficient. Zero configuration is possible through two methods, MDNS, which is Multicast Domain Name System, and Discovery Service. MDNS operates within a local network where devices broadcast their presence, allowing others to automatically recognize them. This system is perfect for smaller networks where all devices are on the same subnet. However, for larger or more complex networks, Discovery Service provides a centralized method of managing device registration, reducing the amount of multicast traffic and allowing for better scalability. MDNS is one of the key technologies that enables zero configuration discovery in NDI. Now, when an NDI device is turned on, it sends a multicast message to the network, essentially saying, who else is there? Other NDI-enabled devices on the same subnet respond by broadcasting their IP addresses, and this process can ensure that devices can locate and communicate with each other without the need for a central server or any manual configuration. In technical terms, MDNS uses multicast UDP packets, user datagram protocol packets, to send discovery messages to all devices within the local network. When a device receives this multicast query, it responds with a DNS message that contains its IP address. This simple yet effective mechanism allows NDI devices to quickly and efficiently discover each other, all on the same network. It's important to note, though, that MDNS is limited to a single LAN, local area network, and doesn't function across different subnets. In larger, more complex network setups, this is where the Discovery Service comes into play. So as we've discovered, MDS is highly effective for small to mid-sized networks, but larger, more segmented networks can often experience issues with multicast traffic. So this is where NDI's Discovery Service provides a really elegant solution. The Discovery Service acts as a centralized registry for NDI devices, reducing the need for multicast traffic and allowing devices to be discovered across different subnets. Unlike NDNS, where each device sends multicast messages, Discovery Service enables devices to register themselves with a central server. When a new device joins the network, it sends its information to the Discovery Service, which then makes this information available to all other NDI devices that are configured to use this service. This method not only reduces network congestion, but also ensures more reliable device discovery in large-scale environments, such as multi-building facilities or cloud-based productions. Discovery Service is configured through NDI Access Manager, and for more complex setups, multiple discovery servers using Linux can be defined in the configuration file and used in tandem to provide redundancy to ensure that device discovery continues even if one server were to go down. In certain situations, automatic discovery via NDNS or Discovery Service might not be possible or even desirable. For example, when devices are located on different subnets or when network security restrictions block multicast traffic, a manual connection may be required. NDI allows you to manually connect devices by specifying the IP address of the sender in the NDI Access Manager. This method ensures that even in segmented or complex network environments, you can still connect and manage NDI streams without relying on automatic discovery. To set up a manual connection, the NDI Access Manager allows you to input the IP addresses of the sender devices, ensuring that the receiving device can access the stream directly. And this feature is really useful in installations when network security policies restrict multicast traffic or where devices are spread across different network segments. In addition to automatic discovery and manual connections, NDI offers a feature called Groups, which provides a powerful way to manage which devices can send and receive streams within a network. NDI Groups allow you to create defined clusters of devices that are visible only to each other, therefore optimizing the workflow and reducing unnecessary network traffic. For example, you might have multiple NDI devices on the same network, but you only want certain devices to be visible to specific receivers. By configuring groups in the NDI Access Manager, you can ensure that only relevant streams are visible to the devices that need them. This improves both performance and security, and it's especially useful in larger deployments where managing stream visibility becomes a crucial part of your network design. In Linux-based environments, NDI groups can also be defined manually by editing the NDI configuration file, giving administrators fine-grained control over stream management. To summarize, NDI discovery and registration are essential components of any NDI-based production workflow. Whether you're utilizing NDNS for a simple small-scale network or deploying Discovery Service for more complex environments, understanding these processes will really help you to ensure that your NDI devices can communicate efficiently. We've explored how MDNS allows for zero configuration discovery in smaller setups, while Discovery Service provides a more scalable solution for larger networks. We've also covered how manual connections can be used when automatic discovery isn't feasible, and how NDI groups can help you organize and manage your streams effectively. Don't forget to take the short quiz, and I look forward to seeing you in the next module. See you soon.